Chapter 10, Section 6, number 11. We're still working with that same data for the data in exercise 11 of section 2. Compute the coefficient of determination and interpret its value in the context of age and vocabulary. So the coefficient of determination was that r squared, and there are multiple ways of calculating that based on data available. Let's jump back over to Excel where I have been calculating things. So we are on number 11. A lot of different ways we can calculate this according to the formulas that were given there in this section. R squared, the easiest way to do R squared, because it's the square of the linear correlation coefficient, is that right up here, I've got the linear correlation coefficient. So I just multiply that times itself to square it. So that's the first way to do it. Another way to do it is looking at, and if we look here, it's the sum of the square root of the y's minus the sum of the square of the errors divided by the sum of the square of the y's. So let's see, d20 is sum of the square of the errors. Nope. d20, oh, there it is, way up there. I had to move the screen a little. So the sum of the square of the y's was that 40133 there in d20, minus the sum of the square of the errors, that was the red one here, out of d38. So that quantity divided by the sum of the square of the y's again. And as we saw here a moment ago, that gets us the same value, the 0.898, which it should, because we're just working different ways with those same terms. We also could have done this by looking at the sum of the square of the xy, that value squared. So let's see, sum of the square of the xy, that was SSXY, and we had that in D21, so we multiply that together so d21 times d21 to get us that square divided by the quantity, the sum of the square of the x's. There's that in the red out of d19 times the sum of the square of the y's, that was d20 in purple this time, we just looked at. So that gets us the 0.898. The third way they mentioned calculating it is looking at the v1 hat. So there we had that in blue, matching the blue, which was in d29. So that was our 4.85. And that's times our sum of the square of the xy, which is in red, there in d21, divided by the sum of the square of the y's, which is in purple this time in d20. So either of those ways, it's all the same numbers as we've been adding and subtracting and multiplying and dividing, pulling it out in different manners. So our r squared is 0.898. So let's jump back here. So r squared is 0.898. or essentially 0.90 or 90%. So 90% of the variation in y is accounted for, maybe between x and y, is accounted for by our proportion. Now, let me reword that one. So the way it says in the definition, it says it measures the proportion of the variability in y that is accounted for by the linear relationship between x and y. So how much of the variability in y is accounted for by that linear relationship? 90% of it. So 90% of the linear relationship between age and vocabulary is accounted for in the regression model that we have. Wow, this was a quick problem, wasn't it?